parts D and E of our limits review, and this is really its own little island. It's not limits, the intermediate value theorem. So here we're trying to show that the given function has at least one root. And remember, a root is the same thing as an x-intercept, also known as a zero. So what we're going to do to try to show this is we are first going to establish that the function's continuous, which it is. So first, f is continuous, and that's what allows you to use the intermediate value theorem, continuous. And then we're going to plug in -2, and we're going to plug in 0. And the hope is that when I plug those two in, one of them's on one side of 0 and the other's on the other. Therefore, we know that f would have to equal 0. So -2 cubed minus 4 times -2 squared plus 7. And then we'll do 0, 0 cubed. Why am I even plugging in 0? 0 minus 0 plus 7 is 7. So that's -8. 2 squared is 4. 4 times that'd be -16 plus 7. -8 minus 6 is -24 plus 7 is -17. All right, there we go. We go from a value less than 0 to a value greater than 0. So f of -2 is less than 0. F of 0 is greater than 0. I'll put an and there. Therefore, we know that f of x must equal 0 somewhere on the interval -2 to 0. We don't know where it happens. We're not solving the equation. We're just showing that f of x does equal 0. Let's look at 19. Same question, but we're on the interval 1 to 6. And so I'm going to first make a note that f is a continuous function. This is a parabola, so no discontinuities, which opens the door to using the intermediate value theorem. So f of 1 is 1 squared minus 7 times 1 plus 9, which is -6 plus 9 is 3. F of 6 squared is 36 minus 42 plus 9. 36 minus 42 is -6 plus 9 is also 3. All right, well, we did not change signs. We're looking for f to change signs. Graphically, right now, what we have is at 1, my function's at 3. And then again at 6, my function's at 3. That does not guarantee that we have a 0 or an x-intercept. So now I'm going to slowly start plugging in the values between 1 and 6. And hopefully one of these between 1 and 6 will give me a negative value, which would guarantee that I have to hit the x-axis. There we go. So I plugged all of them in. And my very first one, actually right here between 1 and 2, I already got a negative, so I could have stopped there. I went ahead and found all the rest of them. But since I see that f of 1 is greater than 0 and f of 2 is less than 0, we know that, therefore, we know that f of x must equal 0 somewhere on the interval 1 to 2, which is on the interval 1 to 6. So that satisfies that answers the question. It turns out that we did also show a second a second x-intercept on the interval 5 to 6. So you're guaranteed, the intermediate value theorem guarantees 1, and in this case we actually found two values on 1 to 6 where the function would equal 0. I think that's it on that one. Oh no, we're doing this section also. So this one, intermediate value theorem again, only this time we're not showing zeros. Actually, this one we are. We're not only showing that we equal a certain value, but I want you to find the value of c guaranteed by the theorem. So this is a parabola, which means f is continuous. And I am wondering if there is a 0 on the interval 2 to 5. So first, I'm going to plug in 2. 2 squared is 4. 4 times 2 is 8. Plus 3, that's -1. F of 5 is 25 minus 20 plus 3, that's 8. And 1 is less than 0. 1 is greater than 0. Therefore, f equals 0 somewhere on the interval 2 to 5. But then we're supposed to find the value of c where that happens. So now we're going to find c, which means we're going to take the function, and I'm going to be technical. I'm actually going to plug in c. So f of x is x squared minus 4x plus 3. So f of c is c squared minus 4c plus 3. And we're trying to find out when that actually equals 0. So we're going to solve that equation by factoring c minus 1, c minus 3. And we get c values of 1 and 3. There are two places where the function equals 0, but remember we're looking for the one that's on the interval 2, 5, which means the only one we're going to keep is 3. We'll toss 1 because x equals 1 is not on the interval 2 to 5. We're looking for the one that's between there. So c is going to be 3 in this case. Next one, we want to show that the function equals negative 2. So we're not showing a 0 this time, we're showing negative 2. Again, this is a parabola, so f is continuous. You always want to make sure your function is continuous on the interval given. So f of 0, that's an easy one. That's going to be 1. So when I plugged in 1, I am above negative 2. I hope that when I plug in 2, I get something less than negative 2. So 2 times 2 squared is 8. 7 times 2 is 14. So 8 minus 14 is negative 6, plus 1 is negative 5. All right, well, 1 is greater than negative 2. Negative 5 is less than negative 2. And based on that, I know that f must equal negative 2 on the interval 0 to 2. And to find the value of c, we're going to plug c into the function, 2c squared minus 7c plus 1, and set it equal to what I'm trying to achieve, negative 2, and we'll solve that equation. So we need to move the 2 over, 2c squared minus 7c plus 3, and we will solve this by factoring. I know my first 2 have to multiply to give me 2c squared. My last 2 have to multiply to give me a 3, and there are only 2 numbers that multiply to 3. I think 1 and 3 is going to work. If that doesn't work, then I'll try 3, then 1. But if I do 2c times 3, that is 6c. 1 times c is 1c. And that can give me a negative 7 if they are both negative. So I'll try minus 3 to get my negative 6 and minus 1 to get my negative 1. And just double checking, negative 1 times negative 3 is positive 3. So it does factor. And then my solutions, c equals 1/2 and c equals 3. And we are looking for the one on the interval 0 to 2. So we're going to toss 3 because that's not on the interval 0 to 2. And the only answer for c is c equals 1/2.